1. Given an arbitrarily sized area, and a set of teamed robots, the goal of heterogeneous multi-robot catching problem is to make sure all teams of the robots can collaboratively catch and suspend the intelligent targets continuously. 2. In our setup, a team of catcher robots needs to suspend and catch a team of intelligent runner robots with the help of other teams of robots, including a team of observer robots and a team of communication robots. We show different objects in this figure. Catcher robots, runner robots, interferers, communication robots, observer robots. 3. The team of observer robots has a larger observational space and is responsible of tracking the runner robots in the air. It provides the information of runner robots to the team of catcher robots. 4. A team of communication robots minimizes the distance between itself and other robots in the whole catching team, securing the communication stability during the whole process. 5. Randomly generated stationary interferers are also placed in the area. All the robots in the catching team need to avoid them during the catching process. In the real experiments, a moving interferer is also added to the system. Given a HMRS catching system consisting of several teams and opponents, and an area for catching in the environment. The HMRS catching system consists of several collaborating teams acting together, with each team having several multi-agent policies. Each robot's the observation is comprised of two different ranges. First, zero-range observations are stacked. Second, local range observation is represented by an image translating and rotating with the ego agent with objects encoded. Then, the zero range and local range observation are fed into a simple visual encoder. The output two feature vectors are then stacked with the zero range observation. Together they forms the latent space observation for each agent. The joint latent space observations of all robots are fed into policy networks and generate the corresponding action vector for each robot during planning, which enables collaborative catching behavior of all the robots in the catching team. Here we show several experiments. At the moment, two of the catcher robots are following the runner robots while the third one is still searching. Now the third catcher robot noticed that two runner robots are being suspended. It tries to find a proper time and angle to help its teammates. Here is another example of collectively deciding how and when to act collaboratively. The third experiment shows a more complicated scenario. At the beginning, one of the catcher robots noticed that its two teammates are already following one runner robots. It decides to look for the other runner robot. However, due to that there is an obstacle in the way, it cannot sustain the other runner robot by itself. Soon there is a new opportunity. Quickly, two catcher robots decided to change the strategy and switch their targets. The previous decision turned out to be effective, letting the runner robots no longer have the opportunity to circle around obstacles. The fourth experiment shows another case. We can see the two catcher robots on the left side of the screen tracking the runner robot one after the other, and the robot on the right also follows the runner robot closely. Eventually, the catcher robots are successful again. We also demonstrate some real-world experiments. The runner robot takes the opportunity to run out of the potential encirclement of the two robots. The obstacle blocks the runner robots, so it stops moving. The white runner robot sees that there is a moving obstacle blocking its way, and it decides to move back. However, it instantly realizes that there is a catcher robot following it. It then turns again, but it is too late to run away. In this experiment, the White Runner robot is accidentally blocked by the communication robot. The catcher robot sees it and seizes the opportunity. It then uses the communication robot to catch the runner robot. This experiment shows another typical catching scenario, in which two catcher robots collaborate to catch one runner robot, and the other catcher robot does it solely. Thanks for your time and attention.